So in the previous video, we talked about series, and these series were technically geometric series. And now what we're going to do, we're going to look at the sum for the series. So basically what happens when I add, if I go back, if I were to add all of these terms together, like let's say part C that we did before, if I were to add all of these guys up, what is it going to give me? Now one way that you can do it is just basically add everything together. But what about if you had 1,000 terms? So how would that even work? Well, luckily for us, there is a formula. So here is a formula for the sum of geometric series. Okay, so I won't prove it to you. This was proven in Math 96, but if you really want to know the proof, it's actually not that bad. But the proof, I'll put it somewhere else. But let's go ahead and do a couple of examples. Okay, so find the sum of the finite geometric series. So let's say we had 3 plus 3 times 2 plus 3 times 2 squared plus all the way to 3 times 2 to the 5th power. Now, usually a lot of them are going to be written like this because it'll be easier for you to see the pattern. Okay, so the first thing to kind of notice is that we already know that this is going to be geometric. The problem already told us, so we don't have to worry about it. Now, all we have to figure out is what A is, what R is, and what N is. Okay, now A is easy. That's going to be 3. That's the first term. N also is going to be easy. Just look at the number. See how it's going from the 1st power, 2nd, and continues on. This guy is going to be just 1 more. So if I add 1, I'm going to get 6. So I have 6 terms. Okay. And now what I want to do is I want to go ahead and figure out what R is. Now, a way that you can do it is take A2 and divide it by A1. Okay, so A2, I get 3 times 2, that's 6, divided by 3, that's going to give me 2. Another way that you could have done it is that because you know what geometric series kind of look like, we know that the number that's being repeated is basically going to be, or the power that's or the base that's having the power is going to be my R, okay? So now all we have to do is just basically plug it into the formula. So this is going to be the formula. So we are looking for the sum of the first 6 terms. A is going to be equal to 3. 1 minus R, that's 2 to the n power, that's 2 to the 6, divided by 1 minus 2. So I'm going to get 3. 1 minus, that's going to give me 64, divided by -1. Putting this in your calculator, you're going to get 189. So basically what this means is that if I were to add all of these numbers up, you're going to get 189. Okay, so plugging it into the formula, it's not really that much. There are some nice applications about this, especially when you're talking about compounding money. There's a lot of different ways that you can kind of use this formula. But what we're really going to be talking about is something called convergence and divergence, okay, which is kind of the key of this entire chapter. Okay, so let's talk about convergence and divergence of series. So we've kind of talked about convergence and divergence before when we were doing improper integrals. And when we did improper integrals, we said that if the improper integral was equal to a number, it would converge. And if it equals to positive infinity or negative infinity, it will diverge. So basically, what we have is we have a series. So we have like A1 plus A2 plus A3. So a whole bunch of numbers, doesn't necessarily have to be geometric, and they're all being added together. Now, what I can do is I can sum up terms. So I can sum up the first term, that's just going to be A1. If I sum up the first 2 terms, that's going to be A1 plus A2. If I sum up the first 3 terms, that's going to give me A1 plus A2 plus A3. And I can continue on until I get to the nth term. I can add up A1 plus A2 plus A3 plus all the way until I get to the nth term. Okay? And I can do this continuously. So basically what happens is that you have 2 options. So basically here are my 2 options. My first option is that all of these sums are getting bigger and bigger and bigger. S sub n is getting larger. So basically saying that it's going to infinity. Okay, but you also have another thing. S sub n is approaching a number, which means you have some value c that is getting closer and closer to it. Okay, so what we say is that as n goes to infinity, so if I keep adding a whole bunch of terms and the limit exists and equals maybe some c, then the series converges. Okay, so if I were to add a whole bunch of sums, and I keep adding more and more, and if it gets closer and closer to this number, then it's going to converge. Okay, otherwise, if the sum is positive infinity or maybe even negative infinity, then the series diverges. Okay, so that's basically what it is. Okay, so now you have to kind of ask yourself, okay, well, if I add a whole bunch of numbers, then that means that the sum should be getting bigger and bigger. Well, that's not the case, because think about this guy. When you have 1, 1/2, 1/4, 1/8, right? 1/16. So notice here that you start off with 1 and you keep multiplying every term by 1/2. The thing is that these numbers start getting smaller and smaller and smaller and smaller to the point that when I add them all together, I keep adding some decimal numbers that it's not really going to affect the total sum, as opposed to if I had 2, 4, 8, 16, where these numbers get bigger and bigger and bigger that are going to affect the entire sum. Okay, so basically when you see that my sequence of numbers is getting smaller and smaller, you can kind of imagine that this is going to go to a number c. Whereas you have a sequence of numbers that's getting larger and larger and larger, then this might be going to infinity. Okay, so when does the geometric series converge? So when does the geometric series converge? Okay, so when am I going to get to a number? So the answer here is when r, the absolute value of r, is less than 1, series converges. If the absolute value of r is greater than or equal to 1, series diverges. Okay, now this is really interesting. Okay, now why is it 1? Well, let's think about it. So if we go back to our formula of summing a whole bunch of terms, well, if you think about this guy, so one of the ones that you really want to look at is the r to the n power. So this r to the n power, so n is getting bigger and bigger and bigger. Okay, so if r is a number that's greater than 1, okay, so maybe 2 to the n power, well, 2 to the infinity is just going to get bigger and bigger and bigger, which means that the whole sum is going to get bigger. If r is a fraction like 1 over 2 to the n, well, this guy is going to get bigger and bigger and bigger, but then since it's a fraction, this is going to get smaller and smaller and smaller, going all the way to 0. So basically, if you have a fraction that's less than 1, okay, and if you go ahead and take the limit of this, this guy is going to go to 0, okay, for r being less than 1. So what that means is that if I were to add an infinite number of terms, when r is less than 1, the absolute value of r is less than 1, then basically you have 1 minus 0 is going to give me 1 divided by 1 over r. So this formula is the sum for an infinite amount of numbers when the absolute value of r is less than or equal to, less than 1. Okay, so if I have a geometric series, then I can find for any number a sum. Okay, and the sum is going to be this formula that I have here for any number. If I have a finite number. However, if I have an infinite number, okay, then this is going to be the formula. Now, this is the only requirement is that we need r to be less than 1. Okay, so in the next video, we're going to do a couple of problems.